Okay, so we're going to start the demo now. As I mentioned before, feel free to interrupt or any of the naive guys can tell me if I'm missing something. So one thing you might notice is that in principle you should, we didn't know that, but you should not be able to access the naive Webgl card. So we're forcing you to use the easy one. Okay, so you just open a web browser. Don't do this with me. Okay, just pay attention because we don't want to overload the server. Okay, so easy way to get there. We've got this link that gets you to our home, and then you simply go for Webgl, and there we go. So I'm going to just maximize. So as Chuck was showing before, the first thing we could do, for example, since we had we did some tutorials on time yesterday, we could go to the time conversion, which is one of the handy things that we can do with Spice. The first thing we should do is that we should select kernel dataset, and as I mentioned yesterday, the flavors are a bit different from the ones that you have available in naive. So you've got first a keyword that is telling you the status of this Spice kernel dataset, then the project that it applies to, and then another description. So in this case here, for example, you have the operational ExoMars 2016 Spice kernel dataset. You also have the planning subset of the operational one. You have the operational for Mars Express. You have archived for Mars Express, as is in the BSA. And as I mentioned to you yesterday, for example, we've got 5 meta-kernels for the JUICE mission, each of them pointing to a different study trajectory. Hence, we have 5 well, you can select 5 scenarios for JUICE. So let's load the Mars Express, the ExoMars one, for example. So one simple thing that we can start with is to convert from UTC time to a spacecraft clock time, so that you can also see how the spacecraft clock string looks like. So we could start with the January of this year. Okay, just put the UTC string. If you had any doubts on the format that we can use, you can always use this help, and here you'll find some hints on the inputs that you can use. And then we can output as a spacecraft clock. We need to put the spacecraft clock ID. So a tip, if you don't remember the ID of ExoMars, probably I only need to Google naive IDs. And the first entry I was getting, it's not this one. That's the one I was looking for. So this is the first entry. So here I can look for the ExoMars ID. Okay, and the TGO ID is -143. Okay, so here we go. So I put the ID here, -143. We want it to have to be in a spacecraft clock string format, and we just compute. And here we go. This is the kind of output that I get. So just a spacecraft clock string. Nice thing that we looked at yesterday is that, for example, we were looking at the difference in between the barycentric dynamic time and terrestrial dynamic time. So maybe we can look at the difference and how it is. We have to change the format here. So let's see what we get. And the difference is it's 0.007 milliseconds. Okay, not bad. Anyway, let's go for something else a bit more exciting, right? So the other thing we can do is that we can compute any kind of geometrical quantity. So for example, we could go for a state vector, and just going to take advantage of the fact that I have the ExoMars 2016 scenario loaded, operational scenario. So for example, we could choose as a target ExoMars, or no, better Mars. Our observer would be ExoMars. As you can see, the field's autocomplete, so as soon as I start typing, I get the options that I can select. We could use the IAU Mars reference frame. And we don't apply any kind of aberration correction. Here would be another option that we could choose. And in this time, instead of using one single time, I'm going to put time interval. And in this case, we're going to start with 1st of January again. And we're going to run for, let's say, a couple of days. Okay. Time step is a sensitive thing because it can, well, it will basically change the performance of the computation. So in this case, I'm going to go for 5 minutes maybe. And we're going to represent this state as a rectangular. And we're going to plot a distance, we're going to use a distance time plot series. And we're going to plot x versus y of this quantity. So let's see what we get. We've got a table with our results. In this case, we get the state. Some graph showing the distance. And actually what I wanted to show you, why don't we just, for example, choose I want to put something else, the sun, Earth, in, we can put 50,000, and we look at, we increase the step to 5 hours, and for example we can look at the XY position of the Earth with respect to the Sun. Let's see what we've got for a year. Well, that was something we would have expected. Okay, so let's go and instead of doing one direct computation, let's use the event finder capabilities. So in this case, for example, what I could do is that I want to show you how you can use the series of time intervals, save them, and compute another quantity for it. So one thing we could look at is, let's see what I want to, before I do that, I want to do something else. Yes, so I just wanted to show you again, for example, now we can load the Mars Express metakernel, and here's the beautiful thing. Now I have both metakernels loaded. So now I can use the ExoMars data and the Mars Express data all together, okay? So one thing that I could do, for instance, is that I could see what is the distance, let's put it a different way. We want to, for example, take a look at the ground track of Mars Express. So that's another thing, I'm sorry. So, for example, let's look at the sub-observer point of Mars Express with respect to Mars. In this case, we can choose different options that are available in the API, in this particular API. So if you want to know more information on it, we can just, again, simply look at this question mark and it will give us some extra information on how this particular function works. Now I can choose to see this for one day. Okay, we're going to reduce the time step to 5 minutes. And in this case, I want to see, for example, with planetocentric coordinates, I want to see the longitude and the latitude, and I want to see the longitude versus the latitude for this particular computation. So look at this, and if I haven't done anything wrong, what we see is basically is the ground track in longitude, latitude, and the ground track as we would see it in a map projection, a rectangular map projection. Okay, so let's look for other things. So let's use the geometry finder, some geometry finder functions. So one thing we could do, for instance, is that we could try to see if we have a given target in the field of view. Phobos is quite nice for this kind of demos. So for example, we could choose the Mars Express high resolution camera. So that's HRC. Let's use the head sensor. In our case now we go for Phobos. Okay. We will model Phobos as a point for this particular search. That basically means that if the center of Phobos is in our field of view, well, then it's going to be, we're going to get results for that. Our observer again is Mars Express. So now what we do is that we put a single interval, and we're going to extend this from January 2016, for example, to January 2017, so that's 1 year of data. We can course our time step, and still we will find the events. We don't really want to do any adjustment to our result window, so let's see the time intervals in which we had Phobos in the field of, did I do it correctly? Yes, in the field of, in the field of view of HRC. Okay, so we've got these series of intervals, and now what we can do is that we can save them. Okay, we can actually save them all. We also get the duration. Okay, and if we click here, they basically what they do is that they appear here in this right side, in this right upper corner as a saved value. So now, maybe I'd like to see what was the angular size of Phobos in those particular time windows. So they are short windows, unfortunately, so we won't see a nice long plot. But basically what we do now is that we choose a list of intervals as an input time. We drag and drop from here. So we've got the result from the previous event finder search. And now we can refine a bit our time step, for example, to minutes. And we plot the angular size for these intervals. Again, we don't see much because it's small time windows across the time span of 1 year. But we can zoom in this graph. Okay, and for example, look at this particular time, and now we see a trend, right? So basically here we were, again, pointing to Phobos with this angular size. Maybe we want to look at the ones which have the biggest angular size, which is here. So that's around, this is around the 14th of July, 2016. Okay, another thing we could do is that, I found this by chance yesterday, is that given these time windows, maybe we could try to see if we also had another object in the field of view during this particular period. So I can put this list of intervals that cover a time span of 1 year, and now I can say, okay, what if we had demos in our field of view as well? Will it happen? So let's just take a look. We compute. And yeah, apparently we've got two results here. So we know that in this interval and in this interval, we had Phobos and Deimos in our field of view. So one thing that I could do now, and just like a nicety and making some publicity, is that I could go to the PSA webpage, the PSA user interface. Okay, here you go. And maybe I could look for Phobos data in these time windows that I got here. So this is 4th of April 2016. Let's take a look. Here, 2016. Oops. But April, we're gonna go from the, let's say, from the 13 to the 15, just in case. We can filter this, and we can look for, now we're looking at Phobos images during this period. Well, my criteria was not good, so that's not where that's not where I was looking at yesterday. Anyway, so the idea is that, for instance, we could do this cascade event finder search with multiple things. So another nice thing, for example, is that now that we've got both the ExoMars and the Mars Express spice kernel dataset loaded, we could look for when Mars Express is occulted by Mars as seen from ExoMars, for instance. That's the kind of observation that both the ground segments are looking at. So we could look for any kind of occultation type, and our front body would be Mars. We would choose for an ellipsoidal shape, and the frame would be Mars. Then our back body would be Mars Express, and we would model it as a point. We don't require a frame if it's not an extended body. And this would be as seen from ExoMars TGO. So here we could put a single interval, for example, starting in April 2018 and until September 1818, for instance. We do a search, and here we will get to see if we have any occultations possible. And indeed, it seems that we have quite a lot of opportunities. So let's see. Here, for example, and it looks like they're really, really long in duration. Okay, so what else could I do? Another thing that I could do, for instance, well, I've shown you the possibilities of the geometry finder functions. Another thing that I could do from geometry computation, let's see. I really wanted to show you that picture with Phobos and names, but I didn't find it. So another one, it's a frame transformation. So for instance, this allows me to compute the difference in between two frames, which might be, let's see, there was something else that I wanted to show you. Yes, okay. So in this case, I'm extracting information from an instrument kernel, so I'm using information from the instrument kernel per se. So let's go back to looking at Phobos. I'm going to put Phobos as a reference frame, and Mars Express as our observer. So in this case, this routine allows me to choose from information that is stored in an instrument kernel. So I could either choose instrument bore site, the boundary vectors of a given field of view, a reference frame axis for Mars Express, or for this, or for an instrument, or I could define a vector in an instrument frame or in a reference frame, which is actually very useful, because sometimes for a given image, for instance, we might have Phobos in the image, but we might not have it intersecting with the instrument bore site, because what happens is that if this is actually not happening, then we will certainly get an error. So if I simply choose this period of time or a single time, well, basically I would be extremely lucky if there was an interception here. So as you can see, the result is no intercept. So in this case, what I should do again is starting with an event finder search. And actually, we've got the instrument intercept finder. So let's look again at this period of time that I was playing with before. And I'll get okay. In this case, actually, yes. So we have to put a coordinate. So this would mean, this would mean that we're finding the interception at, we could put a condition on flag eccentric. We could put a bounding box. So in this case, we would see an interception in a, let's say, in a box that we could select from the body. So for example, we could go from, let's say, latitude maximum 45, minimum minus 45. And in this case, we could restrict it to minus 90 and plus 90. Do our computation. Interesting. Let's see. Oh yeah, of course. We need to select one body that has field of view definition. So in this case, we might have to refine our step. Yes. Oh yeah, that's true. Yes. So it's 1970. Thank you. Put 5 hours. Calculate. No results. Maybe we should refine our time step. And in this case, what I'm going to do is that well, no, I will keep the same interval. Let's change the interval. So maybe we can go back in time. Okay, so for example, we have one result, and the last thing that I want to show you is actually how we can just download a plot from these quantities. So in this case, we're going to look at the coordinates of this surface intercept point. So we're now going to use this. Sorry, I only saved the stop time. Actually, that's true. For this kind of search, I need to, on the outcome, I also need to get the start time. So now I've got the start time and stop time here. Or I could just save all intervals, in which case I would have the full window. And now I go here, I introduce the list of intervals, or as a single interval, but this is it's more handy. So now we can plot longitude versus latitude for this time window, and now we should indeed get this get a result. Oh. So I've done something wrong. Because this is a list of intervals. Sorry. Yeah. So I have to put that as a list of intervals, not as a list of times. Okay, and I certainly need to refine my time step. So now you can put 1 second, no problem. Okay. And I want to show the plot. Now you can simply download the results, so you can download the plot, and you will see that it's been saved, so we've got it as a PNG. I can also go and save the tabular results. Should be available here. So we can download them in different flavors. So, like for example, as an ASCII table, a simple ASCII table. And here we go. So it says that you can use this data with your favorite plotting software. And then the only thing that I just wanted to show you to cross-relate this data with reality is that now probably, and I'm gonna hope for the best but expect for the worst, because I had a different example yesterday when I was running my test. But we can go to this time interval in here, so that's 16th of February 2010. Okay, so we go here, that's February. We'll just extend interval, one more day. Trying to see if we have products. No, they don't have products. What is
You
that?
need to put 17 as a stop time.
Sorry?
It's on the 16th and you limit it at 0 hours. Make it 17.
Okay. I mean, with that good geometry, they should have got
There you go.
forward, right? Yeah, but there's no, well, we don't have any HRC image here. So, let's do one final thing. Do I have time? Yes?
No, you're fast.
I pass time? 3 minutes? Okay, then.
Go ahead.
Yeah, no, it's fine. I just wanted to give another example. So, well, basically, I just went through some of the capabilities that you have here with GeoCalc. The variety of things that you can do is, well, it's big, but it's limited to this subset of functions. And as Chuck mentioned before, probably one of the best use. Well, there's two very good use cases for WebGL. One is that you can quickly, you have like a quick look tool view for, which is handy if you're in a meeting or if you want to show rapidly a quantity. And the other very good usage is to validate your own data, especially if you make sure that you use the same spice kernel data set that, as I mentioned to you before, in the case of the ones which are study, ops, and plan, they are the same ones that you will get if you retrieve the spice kernel data sets from the Bitbucket server. And that's everything.